Hi friends, welcome to GMK Tutorials. Today we are going to discussing one of the most important topic, that is nothing but flip-flops concept, right? So before going to the flip-flops, just you have to see what is meant by latch. Okay, latch. So latch is a storage device. Latch is a storage device which is used for designing asynchronous circuits. Okay, so obviously you have a doubt is sir, what is meant by asynchronous circuits and what is meant by synchronous circuits? Asynchronous circuits means that output of the flip flop acts as input for acts as a input clock for next flip flop. So in case of the asynchronous circuit means that the output the clock for the next one is act as a previous flip flop output. So this is nothing but generally called as asynchronous, or we can also call as a clock is not applied to the all flip flops at a time. So synchronous means the clock is applied for all flip flops at a time. So that is the only basic difference between synchronous and asynchronous. Synchronous means that the clock signal is applied to all flip-flops at a time. So this is very important point for regarding sequential circuits. Okay, so sequential circuits means that the output of the sequential circuit depends on previous input, present input and previous also. Okay, so that is nothing but it depends on both present and past values, it produces the output. So that is generally called as a sequential circuits. Now coming to the latch, so just we have to design a SR latch using NAND gates. Let us see the circuit diagram for this one. This is nothing but SR latch. It is a SR latch using NAND gates. Okay, SR latch using NAND gates. So the characters table for SR latch is nothing but, so generally you know that NAND gate means which produces the output when the both inputs are in a active low, or any one of the input is in the active low condition, which produces the output high. So it is a quite opposite for AND gate operation. So let us see here for NAND gates. Let us consider, I will consider A be the input and Y is the output for AND gate, and Y bar is the output for NAND gate. So what are the possible combination? 0 0 0 1 1 0 1 1. For NAND gate, 0 0 is AND gate means that which produces the output as the product of those two inputs, right? So 0 0 means that the output for AND gate is equal to obviously 0 0 0 1. For NAND gate means that it is a complement of the AND gate, right? So this 0 is nothing but in case of the NAND gate 1 1 1 0. So this is a truth table for NAND gate. Okay, now, so what is the use of flip-flop? What is meant by flip-flop? Flip-flop is nothing but a clock latch. Okay, a clock latch is generally called as a flip-flop. So we need to control the input so that the clock is needed. Okay, so suppose if you are applying the input for the, suppose if you are applying the input for the latch, so you have to suppose flip-flop means that, let us see here, flip-flop means that it is a clocked latch. Okay, flip-flop is nothing but a clocked latch. So in order to control the inputs, we need a clock signal. So for that purpose, a clocked latch is generally called as a flip-flop. Okay, so let us see the circuit diagram for SR flip-flop by using the NAND gates. So let us see here. Yes, our inputs for. So generally previously we know that in addition this, just we are connecting the one NAND gate. Okay, so this part is used for latches. This is a Q, it is a Q bar, right? So in order to control this SR latch, we need a clock signal. So for that purpose, I will take here is a clock signal. Okay, this is a circuit diagram for SR flip-flop. Okay, let us see the truth table for this one. So whenever the clock signal is high, at that time only it produces the output enabled, right? So S R Q Q bar. So let us see, clock is equal 0 means that, so whatever the input, whether X and R, it may be 0 or 1, the output is equal to previous values only, not affected. Okay, not affected. Okay, if the clock is enabled, okay, and S value is 0, R value is 0, at the time it is also maintains the previous values. Okay, that's why it is called as the memory state. Okay, 0 0 condition in case of the SR flip-flop, we can call it is the memory state. So let us see the another possibilities. So when the clock is high, if you are producing S is equal to 1, R is equal to 0, at the time Q is equal to 1, Q bar is equal to 0. So here the output is equal to 1, so that's why it is called as a set condition. When clock is equal to high, S is equal to 0, R is equal to 1, at the time Q is equal to 0, Q bar 1, so that's why it is called as a output is equal to 0, that's why it is called as a reset condition. Okay, set and reset. Okay, So in the last consideration, whenever the S is equal and R is equal to 1, at that time both outputs Q and Q bar produces a value of 1. So it is not used case. Okay. So this is a circuit diagram for SR flip-flop. SR flip-flop. So let us see the possibilities of how this circuit is going to be operated. Okay. So let us see here. I will write the equation for this one. Let us assume that initially we don't know. I will consider S is equal to 1, R is equal to 0, Q is equal to 1, Q bar is equal to 0. So let us assume that we don't know exactly. So I will consider like this. So when S is equal to 0, R is equal to 0, what is the values of this one? So let us check here. So let us see the scenario here. When S is equal to 0 means that S value is 0. What is the previous Q bar value? 0. So this value is also equal to 0. Clock is equal to high. So 0 1 means that any one of the input in case of a NAND gate which produces the output high value. So this is equal to 1. Q bar value 0. 1 0 combination in case of the NAND gates. Okay, 1 0 combination in case. So let us see here 1 0 combination. 1 0 combination 1 0 combination in case of the NAND gate which produces the value of output 1. So which produces the output value is equal to 1. Therefore Q value is equal to 1, and this Q value 1 is supplied as a 1 input, and R value is equal to 0, clock value 1, 1 0 combination again it produces a 1, but 1 1 consideration in case of the NAND gate this value is equal to 0. Therefore when S is equal to 0, R is equal to 0, which produces the output as as Q is equal to 1 and Q bar is equal to 0. So it means that when S value is equal to 0, R value is equal to 0, which produces the outputs as whatever the previous values. So Q is equal to 1 and Q bar is equal to, so same outputs. So that means that in case of the SR flip-flop, when S is equal to 0, R is equal to 0, which produces the previous outputs. So that's why we can call it is a memory state. Okay, that's why it is called as a memory state. So let us see another possibilities. So when S is equal to 0, R is equal to 1 consideration. Okay, so what is the previous value? So Q is equal to 0, same value, and Q bar is equal to 1. Now I will change the S values, right? So S is equal to 0. So 0 1 combination 1. So 1 0 combination is equal to, in case of the so set condition, just we will see the set condition for this one. I will make it as a, wait a minute, then we will come to later. So S is equal to 1, R is equal to 0 condition. When S is equal to 1 and R is equal to 1 condition, what happened? So S is equal to 1 means that now this S1 value S is equal to 1. So clock 1 1 means that this value is equal to 0 for NAND gate realization. So Q bar value is already 0. So this is connected. 0 0 condition in case of the 0 0 condition in case of the NAND gate is equal to 0 0 means that this value is equal to 1. Therefore Q value is equal to 1. Okay. So Q value is equal to 1. This is right. Now this Q is connected 1, but here R value is equal to 0. 1 0 1 combination in case of the NAND gate 1 1. So for 1 1 combination Q bar is equal to 0. So for S is equal to 1 and R is equal to 0 consideration, Q is equal to 1 and q bar value is equal to 0. So that means output value is set to 1. So that's why it is called as a set condition. Okay. Now let us see another possibilities. When s is equal to 0, r is equal to 1, what is the possible combination? So let us change the values. So this is our previous values, right? When s is equal to 0. So any one of the input in case of the NAND gate which produces the output 1 finally, right? So this is 1. So here q bar value is 0. Okay. So what is the q value? Q is equal to 1 means let us see here 1. So R value is equal to 1. So 1 1 combination means that which produces output as a 0, right? So for 1 0 combination which produces output value as a 1. So this is applied to the here. So for 1 1 combination, so let us see here. So for 1 1 combination, for NAND gate output value is equal to 0. So here Q is equal to 0, Q bar value. That means Q is equal to 0, Q bar value is equal to 1. This is called as a reset condition. That means previously this output value is equal to 1. Now it becomes as a 0. So reset means that మనం జనరల్గా ఏమని చెప్తాం Q value 1 నుండి Q bar value next value 0 అయితే reset అయింది అని చెప్తాం. అంటే ఇనిషియల్ వాల్యూస్ కి వచ్చేసాయి 0 వాల్యూస్ కి వచ్చాయి. అంటే so that's why it is called as a reset condition. Reset condition. Okay. So let us see the another possibilities, that is nothing but when s is equal to 1, r is equal to 1, what is the possibilities? Okay, so let us see here. New values are s is equal to 1, r is equal to 1. So 1 1 combination means that obviously what happens, output value is equal to 1. So this value is equal to 1. 1 1 means that NAND gate output is equal to 0. Okay, so this 0 is again applied to here. Okay, so here also 1 1 combination means that for NAND gate output, sorry, 1 1 combination in case of this one is equal to 0. 1 0 combination means that for NAND gate output this gate is equal to 1. So this one is applied as a here. Let us wait a minute, sir. Please, sorry, just I will explain very clearly. Just we can erase it. It gives us some clarity, right? Okay, so previous values are q is equal to 0, q bar value 1. So this is the previous values, right? So when s is equal to 1, r is equal to 1. For 1 1 combination, what happens? This NAND gate output value is equal to, so this is a signal. So for 1 1 combination, NAND gate produces the value as a 0. Okay, so 1 0 means that for NAND gate output, obviously it is also produces a output 1. Okay, this output can be taken as a here. Now for 1 1 combination, again both s and r values are both are equal to 1. So 1 1 combination means that which produces the output of 0, right? Therefore this value is equal to 0. Alright, wait a minute, just I can represent in the upside for its value. So this value is equal to 0 and this value is, so 0 1 combination in case of NAND gate produces again 1. So that means this q value is changed to 1. So for 1 1 combination, q is equal to 1 and q bar value is equal to 1. So this is generally called as a not used because of both 1 1 combination is not used in the practical application. Suppose if 1 and 0, there is a possibility for generation of a clock signal. So for that purpose, 1 1 consideration in case of the SR flip-flop is not used. Okay, this is a SR flip-flop analysis. Okay, so let us check the last condition one more for. We will see one more possibilities. Just when S is equal to 1, R is equal to 0, what happens? When S is equal to 1, R is equal to 0, what happens? Okay, so here Q value is equal to 1, right? Q value 1, so this is connected. R is equal to 0 now. I will write 1, 0 means this value is equal to 1. 1, 1 consideration Q bar value is equal to 0. So this is again applied here. So 1 1 means that NAND gate output is equal to 0. 0 0 means that Q value is equal to 1. So for 1 S0 S is equal to 1 R is equal to 0 condition, Q is equal to 1, Q bar is equal to 0. So it is also called as a set condition. Okay. So this is a analysis for SR flip-flop by using a NAND gates. You can realize this concept for anything. Okay, it may be NAND gates or maybe NOR gates also. Okay, so this is a basic thing. Okay, for SR flip-flop.